Today I will explain the biology of why focus and concentration are a problem in attention deficit hyperactivity disorder. I hope you watched my previous video on the common causes of poor focus, and if not, please do so because all of those factors will apply to ADHD as well. As you know, ADHD is a neurodevelopmental condition which is now being recognized more and more. Often, when symptoms of ADHD continue into adulthood, they can have an impact on every aspect of an individual's life, be it work, be it family, be it social life, and more importantly, overall confidence. When undetected in childhood, many times because the hyperactivity component is not an issue and therefore people go unnoticed. Often, such individuals with attention deficit grow up with a sense of inadequacy, feeling criticized, and therefore have low self esteem that does not help because they feel under constant pressure or automatically assume, I'm not capable, I'm never going to finish a task, I can't get started. One can feel they have not met their purpose or ambition in life in these situations. So, early detection is so important. Now, there is another reason why early detection is very important. Let me explain the concept of brain neuroplasticity. When we break down the word neuroplasticity, neuro means nerves and plasticity means ability to change. We can understand that the word neuroplasticity means the brain's ability to change. There are 100 billion neurons in the brain. In the first years of a child's life, there is rapid growth in the brain. The circuits are expanding as we grow and gather experiences. Some of the connections and circuits in the brain based on usage become stronger while others diminish. As we continue to learn throughout our lives, we see maximum ability to change when we are younger. So now you know that detecting neurodiverse conditions early gives us a better chance to strengthen the circuits in the brain. So, what are the factors that affect the brain in ADHD? Some research tells us that there is a genetic link and therefore ADHD rates have been found to be greater in the biological relatives of children who have ADHD. There are also some studies that have shown some impact of pregnancy and birth related events like stress in the mother, which is called maternal stress, or exposure to substances like alcohol, drugs while in the mother's womb. Other studies have also looked at injury to the newborn brain through low oxygen, seizures, and other such conditions. And then some research has also looked at the impact of environmental factors like difficulties in the family while growing up. So let me tell you what we currently know about the brain circuitry in ADHD. Many parts of the brain seem to be affected in ADHD. I know that many of you don't like technical terms, so I'm just going to show you the areas in this model that are affected in ADHD. So there are areas that are connected by functional networks starting from the prefrontal cortex, the parietal cortex, and then the posterior part of the cingulate cortex. Then they are also connected to the basal ganglia and hippocampus. Studies have shown that there are not only structural changes but also circuitry or connectivity changes in these areas where one has ADHD and therefore affect focus. Effectively, these areas are not working in synchronization in ADHD. So what happens at the chemical end? You may have watched my previous videos where I have explained that chemicals are released between neurons that facilitate the transmission of information between the nerves, and therefore they direct which circuit in the brain will become active. Now, what we know is that the chemical dopamine increases focus, motivation, and drive, and therefore changes the way we perceive or experience the world. It allows us to hone in on certain aspects and sensations like a tunnel, and therefore we focus. On the other hand, if the dopamine is less, the funnel that helps focus is not there, and one experiences a scattered and wide spectrum of sensations. So now you can guess whether dopamine is normal or reduced in ADHD. Low levels of dopamine in ADHD means the circuits between the areas of the brain that I showed are not active the way they should be. Other chemicals are also involved like serotonin, norepinephrine, and there are others, but the main one is dopamine. Let me give you a very simple example of how we can improve our dopamine levels artificially. Now, do you find that your child finds some classes and subjects more interesting based on the teacher? Have you ever wondered why that is? The same also applies to certain work tasks, working in certain teams or with certain people. Do you often think this person is inspiring in appraisals, and after a conversation with them, you feel motivated and focused? And with some other people, you don't feel that. The key ingredient here is curiosity. Increasing curiosity increases dopamine in the brain and improves focus. Similarly, chocolate and caffeine can also increase dopamine artificially, but you also know that they have the opposite effect later on. As a child reaches puberty, some of the task-related circuits improve naturally, and with the right help through early detection, children can transition out of many difficulties of ADHD. So the powers of focus can be improved. Now let's talk about some simple things we can do to improve focus. I have already given 3 strategies in my previous video. Today I'm going to talk about focus on internal states for 15 to 20 minutes daily. There is some evidence that by doing this, our concentration improves because we train the brain to pay attention, learn to be without distractions, reduce stress levels, improve self-regulation, and learn to be in the moment. We become more responsive to the present and less reactive to what's happening. So in today's exercise, let's practice visual anchoring as a way of focusing on our internal state. Choose a quiet place where you won't be disturbed. Sit comfortably with your back straight. Place a large dot or an object, which is a specific point in your visual field to focus on. Make a mark on the wall if needed, or choose a small object, or even an imaginary point, or even focus in the center of your forehead between your eyebrows with your eyes shut. Gently fix your gaze on the chosen point. Try to keep your eyes relaxed but focused. As you maintain your focus on the dot, bring attention to your breath. Notice the inhalation and exhalation. If your mind starts to wander, gently bring it back to the dot and your breath, still focusing on the dot. Allow yourself to be fully present in the act of observing the dot. Notice any thoughts or sensations that arise without getting caught up in them. After a few minutes, gradually release your focus. Blink your eyes if needed. Take a moment to notice how you feel. Slowly build your capacity to practice this for 15 to 20 minutes daily and notice the improvement in your focus and concentration. Subscribe to my channel if you haven't already done so. That allows me more options to make creative videos and share more evidence-based information with you. If you've enjoyed today's video, please like it, share it, tell it. Tell it to all the people you know. Thank you for watching.